Hello people of the internet, welcome. I hope we will have more luck with audio and video than in the previous stream. By the way, if you had some, by any chance, if you watched the previous stream and you had some problems with audio and video, there is a slightly edited version of it on YouTube now that should get over at least some of the problems. So today let's get real with Handmade C++ because there is a problem. And if you have observed my coding style already on the channel, you will know that my coding style is quite unusual for C++ because I hardly use any of the modern C++ features and not even of the not so modern ones. And today I will show you a good case study that really drives the point home why you might want to be very skeptical of modern C++ and template programming and things like that. So I did these things in the past, and they can be fun and expressive and everything, but they have huge problems. And today I will show you very concretely. So this is not an opinion. This is something that I can concretely show you in the generated code today, because I found out the reason for, I think I found out the reason for a problem that we had in the last session. That was that the compile times of my unit tests were getting really large, like into the minutes. So absolutely insane compile times for considering that our unit tests are very small currently. And also the code we are testing is very small. So let's take a look at one of our test files. It has 1000 lines. Most of it is extremely simple code, so either arrays of input data or just lists of test assertions, like check that this integer is equal to this other integer. So the most simple stuff you can imagine, and very useful stuff. So what you typically want to do in your unit and tests. And also please consider, every time I say unit test, this is meant in a very loose sense. So I think in testing you should be flexible and you should show good judgment at which level you test. It's not necessarily the smart thing to test every single tiny function that can lead to a lot of useless effort. So you should judiciously judge or choose the level at which you test. And with unit tests, I also mean things like medium-sized integration tests and so on. So that's actually more what I do here, more in many cases moderately scoped integration tests. Having said that, these tests are really, really simple. So just comparison mostly of integers, booleans, some simple pointer checks, very, very simple. And suddenly this file started to take minutes to compile. And this is in a non-optimized build, so debug compile that should normally be fast. And yesterday after the stream, I noticed something. I noticed, because I always let the compiler output listing files so I can easily check the generated code and see if it's sane. And I noticed when I did my backup of my project directory that the listing files were getting huge. And so let's take a look at one of these listing files. For this test file, this simple test file of about 1000 very simple lines. The first thing we notice is that this listing file has almost 5 million lines. So that's the first shocking thing. Why do you need 5 million lines why do you get 5 million lines from compiling some very simple code that just compares a bunch of integers? That's not normal. So let me just put a marker here so I find this again, this point here. Okay, so let's scroll a bit through this listing file. At the beginning we see some strings and so on. That would be rather expected because these test macros, they actually generate code that can give you nice error messages and so, which is one of the most useful things they do. So nothing out of the ordinary. But then the list of public symbols, start to look at this. I mean, that is already becoming insane. How many public symbols are here? It is crazy. And you see that we have these typical mangled names that C++ compilers generate. And if you look at the unmangling, these are obviously template generated things for printing error messages for different types and so on. So really for trivial stuff. Okay, so lots of symbols. But that's not the worst thing. So let's scroll on. We have lots of stupid traits stuff and C++ streams and so on. That's one of the reasons I never use C++ streams, because they generate such a shitload of code that does nothing useful. And now it gets worse and worse. We find lists of destructors and unwinding information, and it goes on and on and on and on and on. Forever. This is incredible. We are at 8,000 lines and we have not even started to see any useful code. This is absolutely incredible. You can scroll and scroll. 10,000 lines, no useful code yet. Just crap. Crap, 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 crap. Crap, crap, crap. And that is modern C++ for you, people. I mean, sure, you can always blame the compiler and say, yeah, but with Clang or with GCC, this would be much better. I'm not interested, people. If you do something simple, like compare, let's say they are 1,000 integers, compare them with expected values. You should not get a shitload of anything. I mean, that is completely crazy what is going on here. We are at 15,000 lines, no useful code yet. Just garbage, 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 garbage. And it goes on like this. You can look at the whole file. We are not even yet at 1% of the listing file. And by the way, the object is also huge. So it is not only the listing file that is going crazy. Yeah, it's absolutely amazing. So something went completely template crazy in this stuff. So it seems that for every of these test assertions, some template code is generated, and then we have some scope things generated, some destructors, some unwinding information. It is complete insanity. And I want to have none of this stuff in my code base. So today, immediately, I will throw out everything GoogleTest. I'm not interested in this kind of garbage, and I don't want to have it anywhere near my code base. So let's switch to a more positive mode. Cheers. After all this ranting, we will solve this in a positive, constructive way, and we will take it as a good opportunity to give justice to the stream title of Handmade C++. We will now build our own unit test framework that does all the useful things we need and does none of this nonsense that we are seeing here of generating millions of lines of code for nothing. And bogging us down with compile times of minutes and so on. That's crazy. I mean, you really wonder if they ever tested this stuff for some real world use. Definitely it seems not with Microsoft Visual C++. But yeah, let's stop the ranting. Just one thing, if you say, okay, I'm not feeling up to, or rather I am not feeling like writing my own unit test framework, there are definitely saner frameworks. So GoogleTest was just the first one I got into my hands because it has some integration with Visual Studio here. One framework that I used in previous jobs, on my day job, was Unity. So let's see if we can quickly find it. And that was much saner. So because it actually targets embedded systems and is made to be very small, so you can put it on very small bare metal systems, for example. It's pure C, no template nonsense. And so Unity is quite useful, and if you want something that is lean and just works, and you can put it on embedded systems with a very small runtime library support and so on, then this is something to look at. So I briefly considered also using it for my project now, but I think I really want to make it handmade now and roll my own thing. But this is something to look at. I do not recommend going for seedling. So this is the seedling is a wrapper around this Unity stuff and so on. I was not happy with that, but this Unity framework, that is quite okay. So very small and reasonable stuff. So not all are as bad as GoogleTest, but GoogleTest has to go. So, having said that, let's quickly think about what is the minimum viable thing that we need. The absolute minimum, we do need something like expect equal, and it should print, so on error print values. That is very useful, because if it just tells us they are not equal, that is not so useful. We want to see the values. So bonus would be for it to be type safe, but I do not consider this an absolute must. If type safe means that we have to go template insane, we won't do it. Another thing that we need to do, that we actually already do, because GoogleTest did not successfully do it, but we built it our own, is catching. So we definitely want to catch abort and assertion failures. That is very important. We also want to catch access violations. And other hardware exceptions. And if I say catching, it means that the minimum that we want is that the test then fails if something like this happens and we notice it. That's the absolute minimum requirement. Having nice reports on it and so on is a bonus. We also needed to integrate with our test randomization setup. But here the good thing is, this is something I actually coded myself and plugged it into GoogleTest, so we actually have most of the code that does these things. Yeah, what we also want to have, it's maybe not an absolute must, but I want to have automatic test registration, so that we cannot forget to add our tests to a list in order to execute them. Okay, so let us start. How could we do such a thing? Well, something that is obvious is that expect eq will definitely be a macro. We need this at least for reporting the location in the source. We need it to be a macro. And it needs some way to print something, and then it needs some way to exit the test execution, which we can do, for example, with set jump, long jump. We could also do it with C++ exceptions, but C++ exceptions are another thing that I want to avoid, like the plague. And I actually will probably soon configure my compiler switches not to generate any exception handling code, because that is something that can really slow down C++ programs and really blow them up, which I hate. So let's create ourselves a file called should we call it test framework or just test? Let's just call it test. Let's keep it lean. Okay, and let's actually deviate from, so GoogleTest wants to have the expectation value first, but I always find this counterintuitive, and so I always think like this, that first is the actual and then is the expected. This is for me somehow more intuitive. And the absolute minimum that we want here is something like if the actual is not the expected, we need to do some stuff. And this should be always a macro that has statements in it. Should always be wrapped in something that something like a do while 0, for example, that keeps it together as one thing that works as an atomic statement. So you do not get problems if you use it in an if clause and so on. And of course the arguments always need extra parentheses, because the macro substitution is textual and not syntactic. Okay, so what's the minimum that we want to do? Well, the minimum is we want to print an error message. So let's first do things very stupidly. So print an error message, and we will probably later refactor a lot of this. Let's just print. Expected to be something, and now we get a bit of a problem that we do not know, of course, how to really print things. So what we will probably need to do in order to avoid template La La Land is that we will probably need some typed expectation macros. Let's see how far we get. So we expect this, but is actually something else. And for the something else, so I mean we could use C++ streams to figure out the printing automatically, but I think then we will sooner or later run into the same problem with code bloat, because C++ streams, the last time I checked, they generate tons of useless code. So let us do it a bit more explicit. Let's make this actually an implementation macro, and this will get the format for printing. It is actually format. So the first, we will stringify some things. So we stringify them. And print actual. And then let's first do a board. We will later do something smarter, because we do not necessarily want to completely stop execution of the test. But that's the first thing. So then we definitely will need some expect EQ, expect equal for, we can use the same macro for anything that isn't larger than an integer. Or let's say that isn't larger than 32 bits. So 32 bits or smaller, we can use the same macro. Because we can use format D for that. And maybe we also want some hexadecimal, but let's do that for now. And for 64 int, we want pry D64. For this we need the C int types. We will also need standard IO. Okay, we will the same for unsigned. And why not, let's make for hexadecimal output, if we know in the test that we prefer it, why not do it? So 0x, this was wrong, we need this here. 0.16, we want the full width, and this should be x. Okay, these are some of the most important stuff that we need. Of course, we also need some expect true. And let's see, I think we will need to do this separately. So if not actual, so we do not need to print anything fancy for Boolean. And for the expect force, this will just expect the negation to be true. True, not actual. So that's already some of the most important stuff we need. We will also need, so we want two versions of each of these checks. Like GoogleTest does it, that's something they do nicely, is that you always have an expect and an assert. And the difference is that the assert exits the current function if the condition is not true, which is very useful if you check some pointer stuff or array sizes or something, where you know if this isn't fine, then there's no need to look at the rest of the stuff, because it will only crash or produce useless errors. So this is something we want to do, and we will do it by generalizing the macro here to test and having a fatal parameter. And this will work like this, that if, I think this does not need extra parentheses, right? If fatal, we will abort. Otherwise, we need to basically increment an error counter. So something like global number of test failures ++, something like this. We will also look at this later to make this thread safe and so on. So, and then we can actually change all of them to use impl test. And these are the non-fatal ones. So, and then we have exactly the same with assert. And they are the fatal ones. Very straightforward. Same here, so this will be actually an impl test true. And actually we will make ourselves another macro, so impl test fatal that does this. Test failed. What we actually will do here is we want to report line and file. File and line. And so we need an expect true. That will be an impl test true. Test true actual, not fatal, not actual, and the assert versions. Okay. I think those are the most important things we need. So let's give this at least a namespace. Here we'll put our actual declarations. So how was it called? And test failures or something? No? Oh, G, that's my convention for globals. Why is Vim so slow? This is another thing. I mean, I love Vim to bits, but sometimes it's really slow. My OBS is using quite a lot of CPU. Yeah, it's using one core. So we will also need an implementation file. where we actually define things. So that was the first sketch of what we need, is these expectation macros. And let's create a first test where we test some of this stuff. First with an explicit main function. This will later be supplied by our test framework. And so let's just expect something that isn't the case. Sorry. Expect foo to be true, and it isn't true. Why is this so slow? So everything here will become nicer at the end, but let's use this as the first test. Oh, because it's scanning the huge code file. That's why it's so slow. You see, this, I mean, it shouldn't be so slow, but the problem is that things like this crap, that such a ton of code is generated, they have consequences for all your quality of life while you're working on a project. And when people say things like, yeah, but in the end, in the release build and so on, everything will be fine, everything will be optimized away. Yeah, but until then you have to deal with all the crap, and it's really a pain. It slows you down so much. So let's invest some time to get things running cleanly. So let's see if we can build something. First, we need to convince it to run the CMake. Actually, not for release. I don't know why I'm on release here. Maybe because I tried out if this huge mess becomes better in the release build, but we actually want debug. And we want our debug build to be fast because that's the one we use all the time in development. So slow, everything is so slow. Just detecting the compiler, how can this take so long? It's amazing. And now let's see if we have a test target. Yes, we have. In the end, I want to completely get rid of this IDE and run everything from the command line or from Vim or something, because I'm going insane with these tools. So we do not have a board because it's in standard lib, I guess. Nice. Expected food to be true, but it is false. Perfect. Exited with code 0. That's not so perfect. Why did it do that? Because did we not increment this? Test failures ++. Let's first print the number of failures. I have some keyboard problems here. It's always searching through code, this huge code file. Yeah, we don't have anything included. Number of failures 1, and we exit with code 0. Why? Do we need to exit to get a proper exit? Exit with code 0, exit with, or is it reverse under Windows? No. So let's try an exit. Exit 1. So we also need standard library, I guess. Why do we always get exit code 0? Let's check the reference, because I do not understand how to use this. I think there are some macros actually that you should normally use for the unsupported exit codes. Yeah, exit failure. So let's do an exit failure and hope that we get a failure. Code 0. I don't get it, people. What is going on? I'm missing something. Exit 0. So let's run it from the command line. Let's actually make ourselves. Do I have Vim here? No. No, I should fix that. I think it's called the error level, right, in Windows. Ah, okay. To Unix C. And this, yeah, okay. This is actually in out build. Should be here. Okay, does it insist on backslashes? That's funny. Because everywhere else, in all the APIs, you can use slashes just fine under Windows. Echo is on. What is that? That did not work. Error level, is it spelled like this? Yeah, it's spelled like this. Okay, we get error level 1. That is actually, should be fine, error level 1. So let's not do this. Maybe it's just that Visual Studio is reporting it wrong, or whatever is executing the stuff. yeah, we get error level 1. That sounds reasonable. And now let's actually test something that is true. Error level 0. Fine. So our code is actually working. It's just that whatever is executing the stuff here is full of it. So we always get this is incredible. Not even such basic stuff is working. People, what is going on? But our code is working. So sorry for a second. Okay, let me take the opportunity to actually check whether we have audio. Do we have audio? Yes, we have audio. Because in the last stream we had huge audio problems and nobody told me in the chat. Do not leave me alone like this. If there are audio or video problems, please tell me so I can fix it. And actually I should put the chat window on top so I notice if somebody is screaming at me. So please tell me what's up, or if you have any questions or about what's going on, or okay, so we have a first working tiny micro step. And let's take a look at the generated code. Yeah, look at that. 335 lines. Export public symbols. Okay, printf options, vfprint, fprint, fmain. That looks normal. Look at standard IO, printf, yeah, some runtime library stuff. Standard, yeah, this is all for standard IO. Some further runtime library dependencies. Checks checkbars, yeah, that's probably because it's the debug build, I guess. Shutdown, very lean, very nice. What do we have here? DC name, yeah, whatever, don't know. And here, actually, already in line 114, we have some code. This is debug stuff, so it is poisoning the stack with OLCs and so on, so that's only in the debug build. And then let's look at what our expect true does. You see how direct this is? It's just a test instruction. Here we actually have the printing and the abort. I think this gets the file handle for standard error. Yeah, file handle 2 for standard error. Very nice. Straightforward code. What do we have here? vfprintf. Okay, that's just some kind of wrapper around vfprintf for passing these options. Whatever. That is how reasonable code looks like. And code that does not come from C++ or modern C++ la la land. So what should we do? Let's try out some further stuff. Let's have a variable. and we expect that it is equal to 124. Let's run it. Failed. Expected variable to be equal to 124, but is actually 123. Perfect. That's all I wanted to know. No crazy template stuff required. I actually wanted to show you something here. I called it remember this, I think. Remember this. So if you still don't believe me that all this modern C++ stuff is absolutely bogus, just read comments like this. You have to, for context, remind yourself that here people were writing a test framework. A framework that is literally for comparing integers and stuff. So is this number equal to this number? And if it isn't, give me an error report and fail my test, okay? Now let's look what they wrote here. With the following statement, during unqualified name lookup testing, internal to operator shift left appears as if it was declared in nearest enclosing namespace, blah, blah, blah. Blah, 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 blah. For more details, refer to the C++ standard section, so and so. This allows us to fall back, blah, blah. And so on. Assuming T is defined in namespace foo, in the next statement, the compiler will consider all of. It does some lookup of these overloaded operators, and thanks to you, there's some König lookup and blah, blah, blah. And we allow number 2 to be a candidate, as sometimes it's impossible to define number 1, and so on. And this is the command for this line here, for writing a freaking value to an output stream. And that's really sums it all up. I mean, you need a freaking PhD to write a value to an output stream. That's not normal, guys. There's something really wrong here. And the problem is that you can start to enjoy this stuff and enjoy how smart you are, and that you know how to understand an error message going over 10 lines because of some internal template problem, and then you know, aha, it's because this kind of König lookup thing or whatever, and that this is not found and the compiler thinks it is, and you know maybe some boost template that they can use to rectify the situation and so on, and you think, wow, I'm really a elite C++ programmer and so on, and maybe you are, but the problem is you actually are filling your brain with completely useless knowledge that is just working around problems in the language, and instead of getting useful stuff done. And I think these comments, they perfectly illustrate the problem, because you always need to keep in mind the people who wrote this, they were not solving a complicated problem. They were just writing a freaking test framework that compares numbers and other simple objects. And these are the complicated thoughts they needed to have for this. This is completely nuts, people. This is really, it's just insane. And the problem is, if you're in the middle of it, you don't even notice it, because I also was in large C++ projects with millions of lines of code, and we were doing template heavy stuff, and you start to think that this is normal, that things should be so involved and complicated, and you are proud that you can solve the problems. But yeah, if you take a step back, it's really just craziness. Okay. Now for the more complicated stuff. We will need one thing I definitely want to do is, for example, if I have an assertion triggered here, currently we will just fall out of the, yeah, I don't even have assert. Currently we will just fall out of the executable and hit something like this. Abort has been called. What we really want to do is we want to catch this and register it as a test failure. And for this we will need to install a signal handler, which we actually already have in the code for doing that. But it means we will need to have some kind of wrapper around our test functions. That is the next thing we will do, but first I will get myself a glass of water and I will be back in a few minutes. No, I want this. So, see you in a few minutes, people. I am back, hopefully with audio. Have we got audio? Seems we do. So let's get started on some of the more slightly challenging stuff. Because what we actually want to do is we probably don't want to write our tests in the main function. We want something like this, test, and then give it a name. Maybe I will keep the convention that GoogleTest uses, that we have a test suite name and a test name. So we look something like this, like my test suite and my test. And then we will actually do stuff like this inside. And one thing we would like is to have this automatically registered and executed. So let's do that. How could we implement a automatically registering test? Here I think I will use some C++ trickery, because it's the easiest way I can think of doing this. Because if you want to automatically run code, one way to do it is to put it in the constructor of a C++ object. So let's do that. And then hopefully there are some rules that specify that this constructor must actually be executed. I'm not completely sure about that. Maybe I should research that off stream. But for now, test will be a macro. It has a suit name and a test name. And in the end, it will define a function. So something like test function suit name concatenated. So here we also need some concatenation to concatenate the tokens. Suit name, stringified test name. So with this we should, and then the block is following and will create this function. We will also need to register the test. And for this, we will let's try something. We will create a variable that we will put in an anonymous namespace, I guess. And it will be of type, will be in our test namespace. Should actually be like this, test namespace, and will test is registrar a word? I need to check if that is a word. Yeah, it's a word. I don't know if it's a good word, but test registrar, and we will call it test registrar for suite name test name. So this will be the name of a variable, and we will pass it we will need to initialize it we get the suite name, the test name, and it will get a pointer to the test function. Okay, so we will need a prototype for the test function. So let's copy this here and here. And here we will have the prototype. Yeah, let's see if something works about this. So, our test registrar will be a struct, because private is bogus and protected is even more bogus, I think. Or, I mean, they're both just annoying. It will have a constructor, which I normally don't like, but in this case, we need it. And okay, we will probably need a function type for convenience. So type def test function will be something that for now returns void. It's a pointer to a function with no arguments. Test fn. And for now, let's just print test being registered. Just to see if this thing is actually executed. I don't know. Normally I always make destructors virtual because it avoids a lot of problems, but I'm not sure that I want to have a v-table at all in this for this structure. So okay, so we will actually need to remember the suite name and the test name. A test function, I don't know if it, yeah, maybe. Let's remember all of it. Wow, this reminds me so much about my old C++ times when I was writing code that always looked like that, which I no longer do. Sorry. test function. Let's see if this works. It would work maybe if we wouldn't have made lots of syntax errors. We are missing a semicolon. Okay, I don't immediately see where we are missing the semicolon. Can we see what this expands to, please? I would be interested. Error type, error type. And this is not understanding things. Test function, illegal use of type void. I think I need to see what the preprocessor is doing here. So let's see how to do this with CMake. Okay, won't work with the Ninja builder, that is great. Okay, we can do a custom command, of course, but actually I would like to get them on the side. So let's see if Visual C++ pre-processed output, if we can see it on the side. Pre-processed to file. That looks like what we want. Okay, this suppresses compilation. So we can do it . So we can do it for debugging things. Let's try. Let's try. We do a /p. Let's try something like this. Target compile options. I do not understand how to use it. By the way, I think the CMake system might be one of the next things on the list to get rid of. I think I need something like this public or private stuff that I do not fully understand what it is for. Because these times I also consider unacceptable how long this takes. This is crazy. So let's see if we got some preprocessed output. We did. So let's look at it with a useful editor, not with a useless one. Oh, stupid me. Stupid me. I stringified too much. I stringified too much. So the only thing to really stringify is here, where we pass it as a character array. Nice. Our test is being registered and unregistered. Now we need to build a registry for the tests. So let's have something like a test registry. And I think I will do this with a very stupid linked list. Actually, we can use the registrars as the nodes in the list. So let's forward declare the registrar. And let's give this a next pointer. So first test will be initialized to null pointer. This test registry will be a singleton. So normally you could do a singleton pattern with get instance and something like that. But that's really stupid, I think. So we will just, I think we just something like this, the registry. The only thing is, if we do it like this, we might have an ordering problem. We might have an ordering problem for the constructors. So what if we just make this a plain old data thing? And put it, just simply put this thing in the data segment. Filled with zeros. And that should do the trick, right? I mean, that should be always there. Once the loader has loaded everything, this should be there and should be valid. And so the registrar will register itself. And it will register itself at the end, I think, of the linked list. So let's do that. I think it works like this, right? And then you put yourself here. And let's make ourselves a debug function. List registered tests to a file pointer. This will just walk the registered tests. So in our main function, we will call this debugging list the registered tests to standard out. Let's make a second test so we see if the order is correct. My test 2. This will be doomed to fail. So many mistakes in so little code. Why cannot I program? Yeah, this should of course be a pointer. Probably a precedence problem here. Oh, sorry, that is no syntax. No syntax is fail. This is also member next. This is in the namespace test. That's one advantage of not reusing a lot of code, that you can have clean names and you don't need to prefix your website name in front of everything like in Java land, which is the most ugly thing ever. Does not take one argument, really? Yeah, it takes two, really. It takes two, baby. It takes two. Multiply defined symbols. Why is that? Oh, did I write this in the header? I did. This will of course go to the implementation. Don't you love header files and prototypes? They are so great. Yeah, looks like we have a correct list of tests. So I think the next thing we want to do is we want to have a test result type. All right. Why cannot I type at all? So test result types will be unknown, I guess. Passed and failed. Will start out as unknown. No, result. I think I'm getting a bit tired because I'm typing so badly. So, and when we list the tests, we will also list the result. Let's make ourselves a little helper. This is something that really the language should have, but what can you do, people? I don't know, maybe it already exists in the new standards, so if so, please tell me, but last time I checked, you have to do this nonsense by yourself. that's it. Ladies and gentlemen, that is how you do output, and not with C++ streams and templates and garbage that generates mountains of code that do nothing useful. I mean, besides all the rants, I should say that generic programming, I think, by itself is a useful idea. And so generic programming meaning the basic idea that you write code once that can work for different types of data. And that is a useful idea. It's just that the way generic programming is implemented in C++ using templates and the whole type system is completely nuts. And the idea to turn your type system into a programming language in its own right is completely insane. And it makes compilers bloated and slow and useless. Do things work? While we are bitching about other people's code, can we at least make stuff work? Test results are unknown, which is correct. So, what is the next thing we need? The next thing we need is a function to run all the registered tests, right? Run all tests. So run registered tests. Yeah, running tests so and so will be a debug output for now. So if the member function is not a null pointer, we will run it. Okay, prototype missing, the old story. The everlasting story of the missing prototype. How much time has that cost in total? Okay, we are running the first test and it is failing, and we are not running the second test. This is something that we do not like. And we will fix that. But for now, let's make the first test pass. Or not pass, but at least not abort. So the first test is failing, the second is failing. We have two failures. At the end, we will list the tests again. And so far we have not yet reported the results, so they are still unknown. That is something we will need to do. So we can actually run the tests and we get failures registered. We will need something like a pointer to the current test. Which is very simple as long as we are not talking multi-threading. Actually, we can pass the test registrar to the test function itself. That's, I think, a good idea. So the test function will take an argument pointing to its own registrar. We probably should also pass it some larger context like the registry. Should we? Yeah, I guess. It's always better to pass context explicitly. And probably to call this only test is a bad idea, because that is a name that is quite likely to be used in the code somewhere. So when we actually call the test function, we will pass the registry as the first argument and the node as the second one. So we actually have a very, very simple way to get the current test. It's just an argument of our test function. Maybe we should just call it the current test. Because that's that's basically what it is, right? The current test. And if we fail a test, the problem is now, do we want to allow our test macros to be only used inside the function body of the test? Then things are very simple. If we also want them to be usable by functions called from there, then things get more complicated. Because we can, if we want to report failure, we simply can do current test result is test result failed. In any case, we will increase the failure counter. And after running all the tests, so before we run a test, we will always set the result to unknown. And if the result is still unknown after running the test, we will set it to passed. Okay, we're missing some forward declarations, I think. Oh no, we are missing namespaces, that's the problem. Hello spammer, you will be banned in a second. No, I cannot even do that in my own chat window. That is a disaster. But I can do it here. Bye bye, spammer. Scum of the earth. Boy, do I hate spammers. Okay, we have a problem with our function type. And another problem here. I mean, we could do a using here. What is the problem with the function type? Why does the function type not match? Ah, because I also passed the registry, that's why it doesn't match. I should really make this a macro, I think. So both of our tests are failed now. Is that correct? I think it is. I think it is correct because they are both nasty, nasty test boys who fail something. So let's fix the first one so it passes, and let's see if we get the result. Passed, failed. Very nice. Things are beginning to work, people. We are beginning to have something like a small test framework. But of course, it's not yet really good, because if we do, for example, have an assertion, we fall out of our shoes and do not get the rest of the tests run. This we need to fix by installing a signal handler. The good thing is we already do this in our test utilities, so we know how it works. We need test signal. We have this kind of signal handler, so let's put something like this in test CPP. Yeah, we will do kind of an imper namespace. So what is the type of the saved signal handler? This probably has a horrible type. Sorry, what am I doing? I'm getting a bit tired, people. Yeah, horrible function type. Amper signal handler. And now the problem is that the signal handler does not really get any data passed. So what the signal handler could do is could store something in the registry. But we could also do a set jump, long jump. Let's do a set jump, long jump. Good old school way. So I think it worked in a way that you call it here. It returns 0 on direct invocation, and it returns a 1 if we actually come from the long jump. So jump buffer. The jump buffer, we can put the jump buffer in the test registry, because that's our singleton object. and we call it jump out of test. Okay, it's a macro, so that's why it's not taking a pointer. I was wondering. So, where am I? Yeah, here. Jump. So, if we go here, we came here by long jump. That means there's a problem with the test. So we will fail. Else, if it returns 0, it means we have successfully installed the handler. And now in our signal handler, we will simply long jump. Where is the signal handler? I'm getting blind. Here it is. Let's do the long jump, ladies and gentlemen. We are afraid of nothing. I think it takes also an argument. Aborted test. That's nice. Failed. I think it's starting to work. Yeah, because otherwise this would have passed. So only due to the assertion we failed the test. Passed, failed, yeah. And if we now do the assertion, abort, signal caught, aborted, and now it's failed. Very nice, and the second test is run. Yeah, those are the beginnings of a working test framework. What we should consider is, we should actually have a unified way of reporting test failures. So that we use in our macros and also here, maybe with some nice message attached and so on. So I think let's take a final look at the generated code, and then I will take a break. If you have any questions so far about what was going on, so about any details, just ask them. We can look at things. So the point of this is to completely get rid of GoogleTest and have a more sane and much faster testing framework for our needs. So we have some strings being generated. How we are now at still below 1000 lines of listing file. And it will be very interesting at the end to compare the object file sizes and the number of lines in the listing file between the craziness that is GoogleTest and what we will have with basically the same functionality with our solution. We might not have all the magic for different types and so on, but it will be just as fine. And we will have a much easier time customizing things. We won't need any funky event listeners and so on like we needed to do for getting the test randomization setup working. All of it will be much easier. And we will be just as powerful for doing our testing. Okay. So, no questions coming in. People, you are so quiet, or maybe you do not exist. Do you exist? Some viewers exist. That is nice. I hope you are fellow human beings and not procedurally generated NPCs or something. I hope to see you again. And if you made it so far, I hope you enjoyed the stream. So, see you later. Bye.